Hello IB, today we're looking at 22F, tree diagrams. This is probably not new, you've done these in year 10 and we've also been already talking about them in class or using tree diagrams already to solve these probability problems. They're really good to work out your sample space, especially for multi-stage, especially if you've got more than 2 stages. So in a probability tree, remember that all outcomes should be represented. Your probabilities of one group vertically should always add up to 1. They should equal 1. And you multiply along the branches to get your probability, whereas your anything probabilities you're doing vertically is adding. So in up and down you're adding, and along the branches multiplying. So in this first example out of 22F, this question 1, if we've got students in a class playing musical instruments, 60% are female, 20% of the females and 30% of the males play the violin. So if we know that we have 0.6 of the class of females, then that means that we have 0.4 are males, because these need to add up to 1. The class is either male or female. Then for the playing the violin, we're told that 20% of the females play the violin, so that puts this at 0.2, are playing the violin, whereas 30% of the males play the violin, so for the males we have 0.3. So that's what the question tells us. So now we can fill in the gaps. If that's 0.2, then this must be 0.8, or 80% that don't play the violin. And here 0.7 of the boys do not play the violin. So there's our tree, and our sample space we can clearly see is going to be like female playing the violin, and then female not playing the violin, etc. What's a probability that a randomly selected student is male and does not play the violin? So in other words, we're after the probability of male and not playing the violin. That's going to equal male, the probability is 0.4. Not playing the violin is 0.7, so we multiply because we're going along the branch. So that gives us 0.28. What's a probability that someone plays the violin? Then we think we'll come back to our tree. If they play the violin, then we're either this option here, female and playing the violin, or male and playing the violin. So we've got 2 different probabilities for that one. So the probability that they play the violin equals, for the females, it'll be 0.6 times 0.2 plus, for the males, 0.4 times 0.3. And then putting that into your calculator. And so we can see that comes out at 0.24. In this example here, in the same story, we've got, we can use trees to solve this one, but let's just see what the situation is. Suppose this spinner is spun twice. I've just taken some parts of question 3. In part B, find the probability that black appears on both spins. So for B, if we want the probability for the 2 spins of getting black and black, the question to ask, is it dependent or independent? These is an independent events because they don't affect each other, and the probability of getting black is a half. So to get it on both spins, it'll be a half times a half, which is a quarter. Whereas the probability that yellow appears on both spins, the probability of yellow, this area here is only a quarter. So again, independent events, we can just multiply. So we get 1 on 16. Find the probability that the different colours appear on the two spins. So that's where you then need to go, right, well, let's go to your tree. That might be a good way of doing it, rather than to try and think through all the different options. So if we do a tree, we've got 3 different colours that are possible. So we could go black, red, or yellow for the first colour. And then once we've done that, for the second spin, we can do the 3 again. Black, red, yellow. Black, red, yellow. And then also down the bottom, let me just fill that in. Then work out your sample space if we want to get the different colours appearing on both spins. Oh, sorry, first of all, you could then think about putting your probabilities in. So the black was a half, red's a quarter, and yellow's a quarter. That's going to be the same on all your branches because it's independent. There's no change in those between spins. So if we want to get different colours, then we're looking at not black, black. We want to go black, red, black, yellow are different colours. Red, black, not red, 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 yellow we want. Yellow, black we want. Yellow, red we want, not yellow, yellow. So then you can just multiply and work out each of those separately. What would be another way of doing the problem? If you see you've got to add up 6 of those, you could just think you want 1 minus the probability of black, black, plus the probability of red, red, plus the probability of yellow, yellow. So different ways of doing it, but remember, you could add up those 3 that have been left out, subtract them from 1. Anyway, we'll leave that and look at it in class. So thanks for listening and have a good day.